Hello, this is the video for the class special topic on data analytics. And this slide is about the data mining for recommender system. So I would like to discuss about the data in the recommender system. And we are going to learn about the data pre-processing, especially how to handle missing values, some kind of data redundancy, and etc. And we are going to learn about the similarity and dissimilarity. And at the end, we will learn about association or correlation. So when you have the data about recommender system, we need to have at least basic information such as user information, item information, and rating. So those three are the most basic data in the recommender system. There might be other attributes, for example, timestamp or genres and etc. Okay. It's just additional attribute. And if you can see in the recommendation data sources, there might be many kind of attributes for our analysis. So if we have those attributes, we will convert them into a metric, something like this. As you know, in the first class, we learned about the metrics. For example, Alice, this is user, Bob, Charlie, Dave, Ethan. And then we have the item, which is the movie, for example, Toy Story, Iron Man, Spider-Man, Pororo, Barbie. And this is the rating. This is the rating. And with this basic information, we can try to do the recommender system. The recommender system data, there might be two kind of data, which is static data and dynamic data. If it is the static data, it is related with the user and item, such as name, gender, maybe the race or the identity. So for the item, it might be related to the title, the category, actor, or date production. But some of them might be related to the dynamic data, such as the user status. So user status can be changed. And user age, every year the age will be changed. Location, social relationship, emotion. So something that might be changed according to the time. And item also can be changed, for example, in terms of the quality or the model, size, the popularity, seasonal effect. Sometimes we also have the transaction data. As we learned previously, we have the explicit rating and implicit rating. So those kind of data might also be available in some of cases. For example, the rating, like or dislike, comments, browsing, purchase, viewing, and etc. So this is an example about the data set. We learn a little bit about the data for the recommender system. This is an example from the Movie Lens dataset. So we have the user ID, we have movie ID, we have a rating, and we have the timestamp. And for every of this ID, there might be some additional information. For example, movie ID 1, it is the Toy Story in 1995. And there is another information about genres. For example, this is about the adventure, animation, children, comedy, fantasy. And the ID3, yeah, this is the movie title, and this is the genre, comedy and romance. If we apply with this data set, then we can do directly with the recommender system, and we can take a look what is movie ID 1. So we can analyze, we can interpret, we can describe the analysis. Now, there might be another kind of data, and the data might be related to some statistical information. For example, I want to know the rating count. So how many people who gave the rating, or the rating mean. Based on the rating, let's say if the rating is from 1 until 5, then I want to know the average of the rating. So we call it, this is a context-based exploratory data analysis. Every of the rating data will be different. For example, if you see in this IMDb data, so we can make the rating as a ranking. So the rating 1, rating 2, rating 3, rating 4 until rating 10, we can check how many people who are giving the vote for that rating. So here the rating 10 has been given by 1 million people. The rating 9 has been given by 500,000 people. And we can also check based on the mean, the average, or the median. And we can also check based on the demographic. For example, who are the users? Let's say the user is less than 18. So this is the age. This is the user who are between 18 until 29. This is the user between 30 and 44, and this is 45 plus. Or we can also distinguish based on the gender, male and female. Or sometimes we can also look at the demographic based on the users. So if it is users from US, then yeah, we can calculate it. If the users are non-US, we can also calculate it. So this is what we call as the context-based exploratory data analysis. It is based on the attribute. So in the data preprocessing, if you learn in the data mining, and it's just a common concept of the data preprocessing, we can do with the data cleaning. The data cleaning means we ignore the missing values, or we fill in the missing values, or we fill in the missing values scientifically. Yeah. And may deal with the noisy data. There might be some issues with the data integration, how we can handle data redundancy. How can we measure the correlation? For the data reduction, it means if we have a lot of data, if we have a lot of dimension, so we can reduce it. If we have a lot of rows, so we can reduce the number of rows. Or sometimes we will do the data transformation. We will normalize, or sometimes we need to make it as a token, okay? Tokenization. So if we deal with the string data, we can make the token, or we can discretize the numerical data. So there are many issues in the data preprocessing. So let's take a look on the very important part of the data cleaning. So data cleaning is a step to ensure the data is well prepared for creating a model. So it is due to the missing values, or I can say it is MV, and noisy data. So let's say I have this kind of data, user A, B, C, and C. Okay. So user A give a rating 1 to item I1. User A give rating 3 on the item I2, and so on. If we want to make a matrix, then the matrix will be something like this one. So the user A give rating 1 to I1. The user A give rating 3 to I2, but there is no rating on the item 3 for user A, and also for user B and user C. So you can take a look that for user B, there is only one rating, no rating on item 1, and there is no rating on item 3. So what can we do with this one? So we call this is the missing value. Yeah, people may have not rated this item because they have no experience with that item, or they do not buy, or they do not watch the movie, or they are lazy to give the rating. Okay. So what is missing value? Then based on the definition, it is a value that was not introduced, or it is a value that was not available. The reasons, user do not want to rate, or user have not purchased the item. So if the user do not want to rate, we cannot avoid it. And if users have not purchased the items, it's also another kind of issue. So how to handle the MV, or the missing value? The easy way is to discard the data. Discard means we just delete, we just remove the data. However, if it is practical, if the MV is relatively small, if it is small, then we can remove it. But if it is too many, so the analysis of complete instances will not lead to serious bias during the inference. So if it is small, then it's easy, just remove it and there will be no bias. But if there are so many missing values, so we can calculate the missing value ratio. So I'm going to show you one example, like this one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 columns. Okay? So we want to check about the ratio of missing values. The ratio of missing values means the number of missing values divided by the total number of observation multiplied by 100. So let's see. In the ID, variable ID, we have no missing values. Okay, this is the primary key. What about the attribute season? In the attribute season, we can see there are 2, 1 and 2. So let's check how many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 data. So there are 2 missing values out of 10 data. Then it is 20%. What about the holiday? So we have 1, 2, 3. Then it is 3 out of 10 data are missing. So we can have 30% of the missing value ratio. So you can take a look here. If we calculate all those columns, so the highest missing value ratio is wind speed. Okay, there are so many missing values. Then because it is too many, we can remove this one. If we can have a standard. For example, if the missing value ratio is less than 50%, for example, then we can replace it. Or we can put some numbers, or we can put some strategy to fill in these missing values. So MV, or missing value, makes performing data analysis difficult. Okay, and the presence of MV can pose serious problems. For example, inappropriate handling of MV could introduce bias. Bias means, if you already have the rating between 1 until 5, okay, but there is no rating between 2, 3, and 4. So everyone just give 1 and 5, 1 and 5, 1 and 5. Okay. Then there will be some bias with this information if we cannot handle properly. It can result misleading conclusion. So if all data has only 1 and 5, and then suddenly you put the data with random values 2 and 4, so it can give a misleading result, and it can limit the generalizability of the research finding. So the other type of problems, we can lose the efficiency. We can and there are some complication in handling and analyzing the data, and it can be biased, resulting from the difference between missing and the complete data. So what we can check more is about the type of missing values. So there are some types of missing value. The first is MCAR. We call it missing completely at random. The fact that a certain value is missing has nothing to do with its assumed value and with the value of other variables. So there is no connection between the one attribute and the other attribute. For example, this is an example of incomplete data. So there are some missing value, okay? So this missing value is the rating has some missing value, and we have the attribute age. So can you guess, is there any relationship between the age and the missing value? Yeah, it's like random. Okay, so we call this is missing completely at random. And in order to check this one, usually we have a complete data. So if you have the complete data, you will see, okay, if it is the complete data, this is 5, and this is 2, this is 5, and then this is 3, 5, 5. Yeah, somehow it is random. And yeah, for example, the data is missing due to the unwillingness of users. So the users do not want to fill in the rating. Yeah. The other kind of missing values is missing at random, MAR. MAR is that the values of the missing data can somehow be predicted from some of the other variables in the dataset. Yeah. So, for example, yeah, the data is missing due to unavailability from younger users, right? Or yeah, parents, father or mother represent the family to rate the items. Okay, for example, if you watch a movie and the movie is only for the adults or maybe only for the 40 years old and older. So yeah, here you can see that the rating from the younger users are not available or missing. Okay. So in this case, yeah, it is missing at random, but still you can predict, you can guess. Okay. So if we look at the complete data, so the rating is available for the younger user, but yeah, if it is missing like this one, we can guess directly. The other kind of missing values, we call it as missing not at random. Missing not at random, MNAR, is the most complicated one, both in terms of finding it and dealing with it. For example, data is missing due to the intention manner of the service providers. So data is missing when the city equals to Seoul. Okay, so yeah, some people have the intention to do that one. So if you look at this data, here is missing, here is missing, 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 and missing. Is there any prediction about this one? Yeah. If you look at more details, okay, you can see that the rating, only the high values are available. Okay, that's correct. So we can have some idea or we have some guess that the rating which is less than 4 is missing. Okay, the rating that has value that less than 4 is not available. So it means they want to provide the good rating only, and they want to hide the low rating. Okay, so this might happen. Okay. So how we can handle with the missing values? The first, yeah, we can just put the neutral rating. So if they are so, yeah, if the missing value is not that high, and if we can replace it, okay, so we can replace all missing values by a neutral rating. So for example, if neutral is 2 or 3, okay, so out of 1 until 5, then okay, let's put 2, for example. So for every of the missing value like this one, okay, this is the from the previous data. We have the tabular data and then we convert it into this matrix. So we can replace this missing value with 2. We can replace with 2, we can replace with 2, and we can replace with 2. So this is the neutral rating. Or you can change with 3 and etc. Or you can use the item-based min. Okay, what does it mean? I have the user A, B, C, and I have the item 1, 2, 3. So let's take a look on the item 1 and check the min. The min is 1 plus 3 divided by 2. Okay, the average is 2. So I will put 2 as the replacement of this missing value. Okay, let's check the item 2. So it is 3 plus 4 divided by 2. So it is 3.5. So 3.5, it is the replacement value for the missing value. For the item 3, yeah, we have only 1, which is 2. So we can just put 2 and 2 as the replacement. What about if we have the user information and we are going to use the user base min? So it will replace the average rating of that user. So let's say I have the user A, B, and C. So I have 1 and 3. Then in order to replace this one, we will do the addition. This is the same with the previous one, but we are going to use the user information. 1 plus 3 is 4 divided by 2, so it is 2. Okay. So 2 will be placed in this missing value of that user. And then 4, yeah, because we have only only one value, so we will replace this one with 4. And also this one, yeah, we will replace it with 2.5. Or sometimes we just put it as 0. Okay. So when we do the analysis, then we know that 0 is nothing, or 0 has no information. So we replace with 0 values to make the analysis much more better. There are many other advanced techniques like k-nearest neighbor, or we can also find the clusters and use the min of the user or item, or some other kind of method like the Bayesian formula, or we can use the regression tree. But I will not discuss those details. If you have interest on this data preprocessing, yeah, you can also search those research interests. So yeah, this is the learning check. Please try to figure out about this data. Your task is to calculate the missing value ratio. Okay, so you already learned from the previous example, and please check based on this data. You need to check what is the missing value for each of this attribute or its column, and we are going to discuss this answer on our class time. Okay, I will stop this video now and see you on Monday.